right? So this side, right? So F net will be 2k q square upon a square. हेलो स्टूडेंट्स, कैसे हैं आप लोग? तो लास्ट वीडियोस में मैंने कूलम्ब्स लॉ पे बात किया था, है ना, वेक्टर फॉर्म ऑफ कूलम्ब्स लॉ। थोड़ा सा एप्लीकेशन देखेंगे हम लोग कूलम्ब्स लॉ का आज। बहुत सिंपल क्वेश्चन आते हैं इसमें कूलम्ब्स लॉ, राइट। जैसा पहला क्वेश्चन देखेंगे हम लोग, दो बॉडी है जिसके बीच की डिस्टेंस है r, राइट, जिसके बीच की डिस्टेंस है r, इसका मास है m, इसका भी मास है m, इस पे चार्ज है q, इस पे भी चार्ज है q, राइट। सो आपको बताना है रेशियो ऑफ q बाय m फॉर द सिस्टम टू बी इन इक्विलिब्रियम, फॉर द सिस्टम इन इक्विलिब्रियम, राइट। तो अब क्या होगा, ये दोनों सिस्टम को इक्विलिब्रियम में रहना है, उसके लिए q बाय m का रेशियो क्या होगा, राइट। q बाय m का रेशियो क्या होगा? बहुत सिंपल है, कैसे निकालेंगे देखिए। होगा क्या, यहाँ पे q इक्विलिब्रियम में होगा क्योंकि ग्रेविटेशनल फोर्स ऑफ अट्रैक्शन लगेगा, राइट। F ग्रेविटेशनल फोर्स ऑफ अट्रैक्शन लगेगा और एक दूसरे पे ये लगाएंगे इलेक्ट्रोस्टैटिक फोर्स ऑफ रिपल्सन, इलेक्ट्रोस्टैटिक फोर्स ऑफ रिपल्सन। तो जब इक्विलिब्रियम होना, दैट मींस व्हाट, इक्विलिब्रियम होना अगर किसी एक बॉडी के बारे में बात करेंगे, राइट, तो F इलेक्ट्रोस्टैटिक विल बी इक्वल टू F ग्रेविटेशनल, राइट। यही होगा इक्विलिब्रियम के केस में। तो इलेक्ट्रोस्टैटिक फोर्स क्या होगा, K Q1 Q2 अपॉन R स्क्वायर, which will be equal to आपका G M1 M2 अपॉन R स्क्वायर, राइट। G M1 M2 अपॉन R स्क्वायर, यही होगा, है ना। तो अब यहां से हम लोग वैल्यू पुट करेंगे तो आ जाएगा आपका 1/4 पाई एप्सिलॉन नॉट, R स्क्वायर कैंसिल हो जाएगा, दोनों के लिए R सेम है, ये कैंसिल हो गया। 1/4 पाई एप्सिलॉन नॉट q स्क्वायर विल बी इक्वल टू g m स्क्वायर, राइट। सो हमें किसका रेशियो चाहिए, q बाय m। सो q स्क्वायर अपॉन m स्क्वायर इज इक्वल टू 4 पाई एप्सिलॉन नॉट g, राइट। सो q बाय m क्या होगा आपका, q बाय m हो जाएगा रूट अंडर 4 पाई एप्सिलॉन नॉट g, राइट। यानी कि यहां देखने वाली बात यह है कि इसका रेशियो आपका डिस्टेंस पे डिपेंड नहीं कर रहा है, राइट। मतलब अगर q बाय m का रेशियो, आप देखिए, और इसमें यहां पे देखिए सारे चीज कांस्टेंट है, ये भी आप देखेंगे 4 कांस्टेंट है, पाई कांस्टेंट है, एप्सिलॉन कांस्टेंट है, g कांस्टेंट है, यानी कि q बाय m का रेशियो एक कांस्टेंट आने वाला है, राइट। क्या कांस्टेंट आएगा वो आप कैलकुलेट कर सकते हैं, है ना। सारा कांस्टेंट 4 पाई एप्सिलॉन नॉट की वैल्यू पता है आपको, 1/9 इंटू 10 टू द पावर 19, राइट, 10 टू द पावर 9, और g की भी वैल्यू पता है आपको, तो यहाँ पुट करेंगे तो ये एक कोई कांस्टेंट वैल्यू देगा, ठीक है। यानी कि ये इंडिपेंडेंट ऑफ द डिस्टेंस है ना। चलिए दूसरा देखते हैं, नेक्स्ट क्या होता है। नेक्स्ट इसका एप्लीकेशन सिमेट्रिकल बॉडीज में होता है। जैसे अगर बॉडीज आपका सिमेट्रिकल है, राइट, सिमेट्रिकल है, सब पे चार्ज q है, सब पे चार्ज q है, बीच में कितना फोर्स लगेगा, सेंटर पे कितना फोर्स लगेगा, राइट। सो नाउ वी आर गोइंग टू कैलकुलेट द फोर्स एट द सेंटर। सो इफ यू प्लेस एनी चार्ज q, सपोज a charge q is already given, that what will be the force at c, force at c, right. So how we will determine the force? If q is not given, then we will put the test charge, right. If q is not given, we will put the test charge. If q is given, it's okay, right, because we have to determine the force, right. So यहां पे देखेंगे, देखिए इसके कारण इस साइड आएगा और इसके कारण इस साइड आएगा, रिपल्सन आएगा, है ना, रिपल्सन होगा, राइट। सिमिलरली because of symmetricity, all are equal and opposite, they will cancel out each other, right. So finally क्या होगा, F net at C is equal to 0, right? अब suppose here now what they have done is they have given the charge minus q here, right? They have given the charge minus q here. This is q, this is q, this is q, this is q, and this is q, right? And it has a side A, correct? Then tell me what will be the net force here. See, for this is also q, right? So it will be repelled by this one and it will be attracted by this force, right? So it will be, if we say it as 1, right? If we name this place as 1, right? So F1 plus this place as 2, so plus F2, right? So vector addition, we will do the vector addition will be done, right? So for vector addition, again, they both are in same line, so we can directly add them. They can be directly added, right? So now we can directly calculate this distance will be how much. See, if that is A, this all will be A, this will be A, and this will also be A, benzene ring, right? Or hexagonal, right? So these are not benzene exactly, but hexagonal, right? So A will be there. So F1 is how much? F1 will be KQ square, right, upon, this is A, this distance is A, right? So KQ square upon A square, right? Let's call it in on this direction, right? So and F2, this direction side we called as positive, right? And this, so this will be positive, and F2 will be how much? F2 will be again attractive this side, so it will be KQ square. We are talking about magnitude, right? We are talking about magnitude KQ square upon A square, right? So F net will be, because direction we have given assigned using the sign, right? So this side, right? So F net will be 2KQ square upon A square, right? So it will be 2KQ square upon A square, right? So like this we can solve different questions, right? Next question we will do. Next question is, suppose a wedge is given. A wedge is given having angle theta, and here they have put one charge having charge q, right? One here a point charge is there, right? Now a wedge of mass m and carrying charge q, right? So, and this is the distance d, right? So this is the distance d. Now you have to find out that for what angle theta this will be in equilibrium, right? So for what angle theta the system will be in equilibrium. The system will be in equilibrium, right? So how we will do that? Suppose for this angle theta, right? So here it is mg, this side mg cos theta, this side it will be mg sin theta, right? This is the force component along this side. This is the force component along this side. इस side में mg sin theta होगा. This will be mg sin theta, right? And because both have similar charge, there will be one electrostatic force Fe, right? One electrostatic force Fe. So Fe will be equal to mg sin theta, right? For equilibrium, right? For equilibrium will, right? So here Fe will be equal to mg. Fe will be equal to mg sin theta. Now what will be Fe here? Fe is kq square upon d square, right? Will be equal to mg sin theta, right? So then sin theta will be equal to how much? It will be kq square upon d square into mg. That's it. Very simple. right? So these are very simple. Just you have to observe the equilibrium, how the equilibrium will be formed, where the equilibrium will be formed, and how you will equate the forces, right? And you have to be able to write the value of F, right? Next question comes as, suppose two pendulums were there, right? Now these two pendulums, now they have been given some charge Q and mass M, both charge Q and mass M. Then what will happen? They will simply start separating, and at a certain angle they form the equilibrium, right? At a certain angle they will be separated by angle. Once the charge is given, they will start separating. Now this angle is theta, right? This angle is theta. You have to find the tension in the string, right? You have to find the tension in the string. Find tension, right? Or they will say find change in tension, right? So find del T, right? Find del tension. So how we will find del tension? That means del T means T final minus T initial, right? So first of all, we will have to find out T final. So this is at the equilibrium position. Why it is at equilibrium position? So if we will see here, right? So this will be the tension, right? This is here weight mg, and this here electrostatic force Fe, right? When they were simply hanged, weight was balanced by the tension, right? So T initial was, you can write with this pen, T initial was mg, right? Weight was balanced by the tension. But what happened once the charge is given, right? So now they started moving. Why they started moving? Because this weight component cannot balance, initially the weight component cannot balance the force component because they were perpendicular. Now with this tension in the string, now this tension component will balance both, right? So now tension component will balance both. So if this angle is theta, right, this angle theta, this angle will be 90 minus theta, right? So what we will do, see, this angle will be how much? This angle will be 90 minus theta. So this angle will be, this angle is, okay, we will do like this. This angle is theta. So this angle will be theta. This angle is 90. So it will be 90 plus theta, right? So this angle is 90 plus theta. Now what we will do, we will not take the component. We will apply Lami's theorem, right? We will apply Lami's theorem. T, this angle 90 degree, right? And this angle is, we say this angle is 90 plus theta, right? This angle is 90 plus theta. So we can write it as T upon sine 90 will be equal to mg upon sine 90 plus theta, right? So this component will be balanced by this. So T upon sine 90, this T upon this will be equal to mg upon this 90 plus theta, right? So from here T you will get sine 90 is 1. So mg upon cos theta, right? So T you will get as mg upon cos theta. But here you have to find out in terms of Q and M, right? You have to find out in terms of Q and M. Or here you can say now, or we can directly use this, see, using Lami's theorem also you can do, or you can do using this simple addition, or simply taking the projection, right? So this is theta 90 minus theta. So T sine theta will be equal to Fe, right? T sine theta will be equal to Fe. So tan theta is basically, tan theta will be equal to how much? From here also you can say, if this is mg, right, and this is what? This is Fe. So tan theta will be Fe by mg. Tan theta will be Fe by mg, right? From here you will find the sine theta, cos theta, right? So from here you will find the cos theta, tan theta is this. So here cos theta will be how much? So from here you can find the tension, right? So right? So this is T, this is theta, this is mg, right? And this is what? This is Fe, right? So T will be equal to, or you can write T will be equal to root under mg square plus Fe square, right? So this will be the magnitude. You can directly like this, you can write, right? So T magnitude will be root under mg square plus Fe square, right? And tan theta is equal to, and tan theta for theta, tan theta will be equal to Fe upon mg, right? So directly be accepted, right? So these are the applications, right? So there are n numbers of applications for the Coulomb's law, even pendulum, simple pendulum, and all those things are there, right? So this is all for today, and let's see what we can bring in the next videos. So okay then, thank you. We'll meet in the next video. Thank you. Bye.